Very good morning, dear students. Welcome to Purnachandra Higher Secondary School. Okay. So we are going through a chapter that is your circular motion. Okay. So in this chapter, circular motion, let us discuss a very important and interesting topic, that is your banking of rod. Clear? Okay. And why the necessity is required for banking of road. What is the necessity? What is the reason behind it? Why the roads should be banked? Okay, so let us discuss about these things. So first of all, let us discuss. Let us what is the necessity of banking of road? Clear? So suppose a car is moving. Listen very carefully. Suppose a car is moving in a cart path. In a cart path, then what we will assume now? We will assume that the car is in circular motion. Very simple. Okay, if a car is in or is moving in a cart path, then we will assume that the car is in circular motion. Clear? Okay, that means a centripetal force is necessary to have this type of motion. Clear, all of you? Okay. So now, this centripetal force is required to move the car in a cart path, in a circular motion. Clear, all of you? Okay. So now, in this type of motion of a car in a cart path, the necessary centripetal force is provided by the which type of force is provided by the frictional force. Is provided by the frictional force. Look at here. That means, first of all, we assume that the cart path is a horizontal path. The cart path is a horizontal one. Clear? So, if the cart path is a horizontal one, then this type of, that means the reaction force is your in the normally upward. Okay, the weight of that vehicle becomes mg, becomes downward. Clear? And the your coefficient of friction in between the road surface and the tires of this vehicle, again I will repeat, mu is the coefficient of friction in between the tire of this vehicle and the road surface. Clear, all of you? Okay. So now in this type of your curved path, where it is a horizontal path, a curved path, it is a curved path, but it is horizontal one, it is not a banked one. Okay, so what is the main disadvantage we will get? Okay, so if the m is the mass of the vehicle, if m is the mass of the vehicle moving with a velocity v, okay, in a cart path, okay, and r is the radius of curvature of the path, cart path. Clear? Okay. So what we will now the necessary centripetal, just I have told you that in this type of motion, in the first type, the necessary centripetal force is provided by the frictional force. So what is my centripetal force? So centripetal force is equal to or is given by the frictional force. Frictional force in between, again I'll repeat, the frictional force is in between the tires of this vehicle and the road surface. Clear? So what is my centripetal force? So centripetal force is equal to, we know that mv square by r, in the previous class I have discussed. So mv square by is equal to mu into the normal reaction. Mu is the coefficient of friction, n is the normal reaction. Very simple. Clear? So that is equal to, now what is my normal reaction? The normal reaction is equal to my mg. So this is nothing but your mu into mg. Clear? Okay, so that implies now this m and this m cancel out. This m and this m cancel out. So what you will get? Now v square is equal to mu rg. So that implies v is equal to root over mu rg. Clear? Okay, so that means this is my, listen very carefully, this, suppose this is, I will give equation number 1. then equation number 1 is the maximum velocity of safety of the vehicle. Listen very carefully. The equation number 1 is the maximum velocity for the safety of the vehicle in a curved path, but the curved path is a horizontal one. Clear? The curved path should not be a bent one. Okay, so if the curved path is a horizontal one, then this is my maximum safety velocity. Clear all of you? Okay, that means if this velocity, if this vehicle continues with this velocity, then the vehicle will not skid from this curved path. Okay, but the problem is that if we want to increase the safety velocity, then what we will do? Now we will have to increase the frictional force. We will have to increase the frictional force, but on the other way, if we will increase the frictional force, then what happens? We have to make the road becomes rough so that the frictional force becomes more. But if we will make the road becomes more rough, then the tires becomes have more wear and tear. The tires become easily gone out, which harms the vehicle. Clear? So that means to increase the safety velocity, we should not wise to increase the frictional force. And on the other hand, if there is some oil or in the rainy season there is some water in the road, in the curved path, then there is possibility of decreasing of this frictional force. Okay, so for which the velocity decreases, and there is chance of skidding of this vehicle in a curved path. Understood all of you? Okay, so that means the increasing of the frictional force is not a wise method for this. Okay, so for this what we will do? Now the wise method is to apply or to adopt this method, that is banking of road. Okay, we have to make the road becomes banked so that there is no skid happens to the vehicle, and the passenger inside the vehicle becomes more feel safer. Now let us discuss what do you mean by banking of road, or how we will bank the road. Let us discuss. Okay. Okay, so now let us discuss that how we will bank the road. Okay, so banking of road is nothing but a process. Listen very carefully. The banking of road is the process of raising the outer edge of the road over the inner edge. Again, I will repeat. The process of raising the outer edge of the road over the inner edge, okay, with some particular angle is called your banking of road, as you have seen in this figure. So look at this figure very carefully. Okay, as you have seen in this figure, this figure, look at here, this is your horizontal, okay, and this is your angle of banking. Clear? And this is my surface. That means this is here in this case. Look at here. In the first case, there is also a curved path, but that curved path is a horizontal one. Okay, but look at this. In the second part here, we make the path becomes bent one. We make the road becomes bent one. How? Because just I have discussed that the process of raising the outer edge. So this is your outer edge of the road. This is the inner edge of the road. So we have to look at very carefully. We have to raise the outer edge of the road. Okay, with or over the inner edge with some angle theta. Clear? So that the road becomes bent one. Clear? Okay, and this angle, what the road surface makes with the horizontal, listen very carefully, this angle, what the road surface makes with the horizontal is called your angle of banking. Here the theta, this theta is called your angle of banking. Clear? That means we can simply, here I have noted OA is your horizontal, OB is your road surface, where the BS becomes raised over the SO. Clear? So this type of road is called your banked road. Then what is the advantage? Listen very carefully. What is the, let us first find out what is the advantage of your banked road, or why should you require the banked road? Because just I have previously discussed that in a curved path which is horizontal one, what is the maximum velocity? Now V is equal to root over mu ZR in a horizontal path. What do you will get? The maximum velocity of safety. Now V is equal to root over mu RG. Just I have discussed. Just I have discussed that the velocity of safety V is equal to root over mu RG. In which case? In a case where the path become horizontal one, though it is a curved path. Okay, but in this case now we have discussed the road becomes a banked one. Okay, so all of you look at this one. All of you kindly look at this figure very carefully. When the road become banked, what are the forces? What are the forces applied on the vehicle? Let us discuss first, which is very important. Clear? Okay. So now what are the forces? All of you look at the figure. Again I'll repeat. All of you look at the figure. Okay. This is the real-time figure and this is the free body diagram. Again I'll repeat. This is the real-time figure and this is the free body diagram of this one. Clear? So what are the forces? Let us see. So this is my object, the box one is your car or vehicle, any vehicle. Okay, so now what are the forces? First of all, one by one I have discussed. The first force, here I have to mention one by one. Okay, the first force is your mg, that is weight of the vehicle. Mg is weight of the vehicle. Okay, which is becomes, look at here, which is becomes downward. Okay, clear? Then your n is the normal reaction. Okay, which is, look at here, which is perpendicular to the road surface. Yes or no? Which is perpendicular to the road surface. Then F is nothing but your frictional force. F is your frictional force. Clear? Okay, so now one by one I want to resolve. Every force will be resolved. Clear? Now how the resolution takes place, all of you look at here. One by one I have to resolve. The n, the normal reaction, this is the angle theta. If this is my angle theta, then this is my angle theta. Clear? So if this is my angle theta, the n, okay, you can look at this figure and you also can look at this figure. This is a free body diagram. So let us look at this. Okay, so now this is my normal reaction. Clear? So this normal reaction is perpendicular to this or is normal to this surface, road surface. OB is the road surface. So now this n is split or divided into two components. One is a horizontal component m cos theta, another one is suppose this is my vertical component m cos theta and this is my horizontal component your m sin theta. Clear? Now this is my force, frictional force. Look at here. This is my frictional force F. Okay, so this is my frictional force F. The frictional force is in between the road tires, of the vehicle, and with respect to the road, in between the tires of the vehicle and road. Okay, so this F is again divided. This is my angle theta, when this F is divided into the horizontal component, the vertical component. So F is divided into F cos theta and this is F sin theta. That means in a simple word or in a simple sentence, okay, I can clearly tell you that, look at very carefully, the n cos theta is balanced by f sin theta plus mg. Okay, clear all of you? Okay, and the necessary centripetal force. Again, I'll repeat, the necessary centripetal force is provided or is balanced by f cos theta and n sin theta. Clear? Again, I'll repeat. Look at very carefully. The m cos theta is balanced by f sin theta and mg, and the necessary centripetal force which helps your rod or object to move in a circular motion in a bent rod. The f cos theta and n sin theta is balanced by that necessary centripetal force. So let us now balance one by one. Okay. So first of all, balance the upper one. Look at very carefully. First of all, now balance the upper one. So, okay, so if you look at here, so what I can write? Now n cos theta is equal to f sin theta plus mg. Clear? Okay, so that implies I can write mg is equal to n cos theta minus f sin theta. Clear all of you? All of you clear? Okay. So now this is the equation from I will get from the vertical components. Now come to the horizontal component. So what I have told you, the horizontal component is balanced by the necessary centripetal force. Okay. So now necessary centripetal force. This is equation suppose 1. Okay, now how you will get this is from the vertical component. These are your vertical components. Okay, now come to the horizontal components. So how the horizontal component can be balanced? So now the necessary centripetal force mv square by r is balanced by what? Now f cos theta plus n sin theta. Very simple. F cos theta plus n sin theta. Clear? All of you clear? Okay. So now this r you can take small, this r you can take large. It is up to you. Okay, because this is nothing but the radius of the path only. Okay. So now that implies, let us take the r capital. Don't worry. Don't worry, because r becomes same. Whether I will take it smaller, whether I will take capital R, but this r denotes the radius of curvature. So don't confuse. Okay. So mv square by r is equal to f cos theta plus n sin theta. Clear? So now what we will do? So this is my equation number 2. Now divide equation 2 with equation 1. Now what we will do? Now we have to divide equation 2 with equation 1. Okay, so let us divide this divided by this. Clear? So what we will get? Now we will get v square by rg is equal to n sin theta plus f cos theta divided by n cos theta minus f sin theta. This I will get. Yes or no? So this I will get. Clear all of you? Okay. So now this v is nothing but your maximum velocity, maximum speed of the vehicle. Yes or no? This v is nothing but your maximum speed of the vehicle. Clear? Okay. So that means we have to mention the maximum speed of the vehicle. Okay. So that implies, now what I will give? Now we will, so that is your v max square. Okay. Look at very carefully. So v max square divided by rg is equal to, okay, so n sin theta plus, so what is f? F is the frictional force, so I can write the frictional force is equal to mu into n, mu into the normal reaction, just I told you, mu into n. So let us put here mu into n. Okay, so mu into n cos theta divided by, this is n cos theta minus mu into n sin theta. Clear? Okay. All of you clear? So now, so let us find out. So this is my equation. Clear? That is v square by rg this much. Now I can take n common and I can cancel out the n. So if I will cancel out the n, then what I will get? Now v max square divided by rg, okay, is equal to sin theta plus mu cos theta divided by cos theta minus mu sin theta. This I will get. Clear? Okay. So now very simply I can convert it to, so v square divided by rg. If I will take the cos theta common, okay, if I will take cos theta common, that means I can write here sin theta divided by cos theta plus mu whole divided by, again this is cos theta, 1 minus mu sin theta divided by cos theta. Very simple, which is nothing but, so the cos theta becomes cancel out, so that becomes your tan theta plus mu divided by 1 minus mu tan theta. Understood? And listen very carefully, this mu is nothing but your coefficient of friction. The mu is nothing but your coefficient of friction. Clear? Okay. So now that implies your v square is equal to rg tan theta plus mu divided by 1 minus mu tan theta. Okay, so this is your v max. So v max is equal to rg whole into tan theta plus mu divided by 1 minus mu tan theta root over. Clear? Okay. This is very important. Listen very carefully. This is very important. Okay. So this is given equation number 2. Okay. So now again I will mention, I want to mention, this is my maximum velocity of the vehicle in a bend road, so that the vehicle should not be skid. Okay, the vehicle, so it is the velocity of safety in a bend road. Clear? But in the just I have told you what is the velocity of safety in a horizontal curved path. The v max is equal to root over mu rg. This is the velocity of vehicle in a curved path, but that is a horizontal one. Clear? So if you compare these two, if you compare this and this is already I have discussed. This is the maximum velocity in your your bend path. Okay, so if you will compare these two, then you will find that the velocity of safety in a bend road becomes more than the velocity of safety in a horizontal path. In a horizontal curved path. That means which one better? This one is a better one. Okay, so that's why the road should be bent. The road should be bent in a curved path where there is a sharp turn, where the vehicle has to take a sharp turn. That path should be a bent one. Okay, if the road becomes a bent one, then the vehicle should not be skid. Okay, so it will move in a safety way. Clear, all of you? Okay, so this is how you can find out, we can compare between a horizontal curved path, between a banked path. Okay, so in these two, the velocity of safety is more easier. To compare these two, I can take a very good example in a racing track. All of you have looked at the racing track, car racing track. Okay, so the car, if you closely observe there, the car racing tracks are slightly banked. They are not horizontal one. They are slightly bent. Okay, so that the velocity, they will get a more velocity, the more safety velocity. Okay, and they can go or they can overcome that car path safely. Clear all of you? Okay, so this is the why we will have to move with the banking of road, and this is the concept. Clear all of you? Okay, so here again I will summarize. The equation number 2 is the maximum velocity for a banking of road, in a maximum velocity of a vehicle in a banked road. The equation number 3, which I have just previously derived, this is the maximum velocity of a vehicle in a horizontal car path. In between these two, this is more, that's why this is more safetier than this in a car path. Okay, so this is for this day. Okay, for this video lecture. Next class we will discuss more interesting point. Okay, if you like my video, then subscribe. Okay, and like it. Okay, thank you so much. Have a good day.